So now we're going to look at the Ogive, the cumulative frequency curve. So it's also called a cumulative frequency curve, as we've already stated, and it can be used to obtain the median. Then the plot remains the same for both equal and unequal class intervals. Now this is very key because it's different for the histogram. The histogram actually varies depending on whether we have equal or unequal class intervals. So now how do we put an Ogive? So it's a cumulative frequency against the upper class boundaries. Upper class boundaries. Okay. Now, for now, let me first give us a general view of how it would look. This is the general structure usually. Now, this axis, the y-axis, usually has to start from 0. Yes, it has to start from 0, but the upper class boundaries doesn't have to start from 0. And note, we are plotting the upper class boundaries. We're going to see this in a bit. So now we can find the median. How do we find that median? We get n out of 2. In the questions we've been seeing, okay, let's say it's 50. 50 divided by 2, what do we get? We get 25. Now this 25, when you come here and look for that value, that n out of 2, which is here, 25, you look for 25. Look for 25, you extrapolate to this, then you, in a straight line, come here. Now the value you pick off is the median. So for cause of time, we can actually even do the Q1 and Q2, that's the quarters, the upper quartile and the lower quartile. So Q1, we said this is a quarter of n. This would be 50 divided by 4. I think this is 12.5. So you would come, this is 25, which is n out of 2. Then you come here, you're getting a quarter n. In this case, it's 12.5. We look for it, extrapolate. The value you get here is Q1. Same thing, you do the same for it's 3 out of 4n. 3 out of 4n. You get it here. Go extrapolate. The value you get here is Q3. That's how we find that's how we use an Ogive to find the median, lower quartile, the upper quartile. So you can find the interquartile range saying Q3 and value from Q1, and get the semi-interquartile range by Q3 out of Q minus Q1 divided by 2. So we found the interquartile range. Okay, so now here we have an example. It's the same example we've been using up, so we can do it real fast. Have our max. This is 50 to 59, then 60 to 69, then 70 to 79, then 80 to 89, and we have the frequency 8, 10, 24, 8. This is a max. So we have to add a column for the cumulative frequency. This would be 8, this is 18, 42, 50. Then we set the class boundaries. So here what do we have? We have 49 to 59.5, 59.5 to 69.5. Then we have 69.5 to 79.5. Then we have 79.5 to 89.5. Now, because of, let me first draw the axis here, then we see what to do. So okay, now we are going to look at an example of how to plot the Ogive, or the cumulative frequency distribution curve. The first thing, what we need on the x-axis, on the horizontal axis, we need the upper class boundaries. On the vertical axis, we need the cumulative frequency. Now, sorry, because at the moment we can't plot this on an actual graph, but we can use this. So we have calibrations. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's say we have that. Then here we can say we have 1, 2, 3, 4, 5, maybe 6. Now, we said as a rule the cumulative frequency side will start from 0. Hope we all remember that. So the vertical should be starting from 0 every time. Now you come to your cumulative frequencies and you see what's the highest. The highest is 50. And this is a rule whenever you're plotting any graph, you should know you get the highest value minus the lowest value divided by the number of squares. But you should not cram the formula. But let me show you what it means. So in the cumulative frequency, we get 50. The lowest is 0. Then we count how many boxes. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say 9. So 50 divided by 9. 50 divided by 9. 50 divided by 9. Now, I should note that the good multiples for use in any of these graphs should be 0, 1, 2, 2.5, 5. The multiples of these numbers are the good things to use in your graph. Now here, since we are getting 5.5, I can round it off. I can push it to 10 because that's also as 1 is here. Though it's going to be somehow big, like the values will be, I don't know if you get what I mean. So this would be 10, this would be 20, this would be 30, this would be 40, this would be 50. This is okay, just that we've not properly distributed it depending, because if here we had one more value, this would be, we could use 5 because there would be 10, but for us we have 9, so that's why I've chosen to use this. This is 60, 70, 80, 90. Then we come to the class boundaries. We are plotting upper class boundaries. Now here we are lucky that these things are uniform. Hope you're getting what I'm saying. These are uniform class intervals, like the space between each of these is 10, 10, 10. So I can actually just see how many are they. 1, 2, 3, 4, 5. There are 5, and I have 1, 2, 3. You have more than that, so I can just plot them the way they are, starting with the lowest class boundary. So I start from 49.5 plus 10, that would be 59.5 plus 10, this would be 69.5 plus 10, that would be 79, then 89.5. You can even say this is 99. Now this usually gives people a deception that always when we are plotting on the upper class boundaries, you just pick out whatever is here and you write. No, that's not true. You actually have to follow the normal rules of scales, because when you have unequal class intervals and you just add, you're going to have a discorrelation in your upper class boundary, which will be wrong. You have to get a normal scale. I don't know if that makes sense. Should have been easier to explain. When we in the exercise, I'll be showing you from different examples and maybe you'll see what I mean. So now here on the lowest class boundary, what we plot is 0. See here we plot 0. Then now we are plotting upper class boundary. So 59.5 we will plot 8. So 8 is around here. So in a proper graph you can be able to locate. Then 69.5 we are plotting 18. 18 is around here. Then on 79.5 we are plotting 42. Go 42 is around here. Then 89.5 we are plotting 50. 50 is around here. Then we join this smooth. You don't use a ruler, do it with a free hand. So this is not smooth because I'm writing digitally, but on a paper it should be much smoother than this. So then this is now let me give you one note. This graph, if I was to draw this graph in a paper, I would have put in 0 on that number. Why? 1, I don't have a title. So all your graphs are supposed to have a title. So a title is supposed to have a cumulative frequency distribution curve or an ogive showing maybe the marks obtained, an exam by 50 students you get. So with your title, come here and put a scale, vertical scale, horizontal scale. Now I've told you that the rules of drawing graphs apply are the same rules from those other subjects, whichever subject, whether geography, their rules are the same. It's just that here you're plotting cumulative frequency and upper class boundaries. Here you have to be careful about these points. So now here, when you have this, there will be a mark there, there will be a mark here, a mark for labeling your axis. Now also another thing that is key usually, people, when I tell you we plot upper class boundaries, when we reach on the graph, you're not supposed to write upper class boundary, you're supposed to write max in percentage. Yes, you're plotting upper class boundaries, but these units are max. Does that make sense? These are max, but yes, you are plotting upper class, so this is just to guide you. But however, on your graph, you just write max in percentage. So you in your head, you know that I'm plotting upper class boundaries. Hope that makes sense. Now, finally, you can also use this to obtain the percentiles. Let me just do something small here. So if I want to get the 90th percentile, I'll say 90 out of 100 times n, then the value I get here, I come and look for it here. I hope this makes sense. You see? You get it, that will be that percentile. That marks the end of the work on the Ogive. However, as you should note what we said, that I've not been able to do on a proper graph here, but you should practice more on a graph. In the exercise, I'll be showing the